Hello everybody, my name is Zivko Stojanov and today I'll be talking about how to build a high-performance services with gRPC. Before diving deep into the technical part, I'm going to briefly mention what is gRPC, what kind of RPC service method types exist, differences between RPC and HTTP APIs, and a short demo. So let's get started. What is gRPC? gRPC is a popular open source remote procedure call framework developed by Google that enables efficient and robust communication between distributed systems. It is designed for building high-performance, language-agnostic, and platform-independent remote procedure call systems. Uses HTTP2 as an underlying protocol and protobufs, known as interface definition language, for describing service methods and data structure. I'm going to mention HTTP2 benefits of using and protobufs on a separate slide. HTTP2, the most significant improvements in HTTP2 is multiplexing. This means that multiple requests and response can be sent and received in parallel over a single TCP connection. We have a header compression. This is a technique in a way for compressing headers, and it reduces the overhead associated with the HTTP headers, which was a problem in HTTP1. Then we have a prioritization. HTTP2 allows clients to specify the priority of each resources, which helps in optimizing the load of critical resources first. We have a service push, where the server pushes some data to the client before the clients request them. This further reduces latency and speeding up the load time of our website. Binary protocol, while HTTP1 uses plain text for communication, HTTP2 uses a binary protocol, which is more efficient for parsing and transmission. Protobufs, known as protocol buffers, is interface definition language, which means that we are defining the contracts for serialization and deserialization, and we are defining and describing only once, and they could be implemented or generated in our language of choice. On the right side, we have a contract defining our contracts, and on the left side, we are modeling or defining the service. The contract, the naming convention for the contract starts with the messages, and we are listing the properties, actual payload. We have a type, property name, and the location. Type property, as in this case GUID, which is a custom type. I'm going to demonstrate that later, how we are building these custom types. This is the request, and the same applies for the reply or response. And the whole flow for transmitting data goes with the binary format for that network transmission. This is on the left side defining the service. We have a service keyword, the name of the class. We have a remote procedure call, a method name. We have a request, and we have a response. We have a 4 type of remote procedure call service methods. The first one is the one that is going to be used in my demo, and that's a unary or normal function call, where the client sends a single request to the server and the server gets a single response back. The server streaming is where the client sends a request to the server and gets a stream to read the sequence of message back, which means the client reads that stream until there are no more messages. And the beauty here is that gRPC guarantees message ordering within an individual RPC call. The client streaming is similar as a server streaming, and we have a directional streaming where both sides send sequence of messages using read-write stream. Uh, Differences or pros and cons with RPC compressed to the HTTP APIs is that RPC, as we saw, we have a contract first. We are defining our contracts, our services, and everything upfront. They are human readable by us developers. We can easily define and describe them in a code, but it's very complex when we are serializing because the whole transmission is with binaries. We need a special tooling for that in order to see the data. And the drawback is also that it hides a lot of complexity and the code that is auto-generated by gRPC tooling. HTTP APIs are well known, and it is like a content first. We immediately think about CRUDs, URLs, JSON. Content is human readable. We can easily serialize, deserialize, and check it. And as its name suggests, it's emphasizing the HTTP. Let's go straight to the demo. For my demo, what I have, we have a console application, which is a client in my case, and we have a .NET API, which is a server. We have a class library where I'm storing the shareable protobuf types, custom protobuf types in a way, so that I can be using them later everywhere in each client or server, in each runtime basically. For example, the custom type, the way how we are building custom types is the following. Here we have .NET 6 target framework for all these runtimes, including the class library. We're installing the gRPC tooling that knows how to generate these all these things with the Google Protobuf and gRPC Net Common. We are defining referencing the proto file, which is basic like a text that is with a specific naming convention, and we are defining the syntax, the namespace that is going to be referenced later, and all these classes and things that by the gRPC tooling are going to be defined in this namespace, and this is the package name that is going to be referenced within the other proto files. We have a tiny wrapper on top of the string, which is GUID, and this is the custom class that is developed by us. Like we have a simple implicit conversion from UID class to string or GUID and vice versa. And as we can see here, this class is partial because we have auto-generated code by a protobuf compiler, and we cannot modify this. And this is something that uh, basically all method properties, calls for serialization, deserialization, equality checks, and everything is being defined here. So we don't need to modify that, and the only thing that we can do basically extend that logic according to our needs. That's in the common part, which is referenced in the service and in the client applications. In the service, how we're gonna use that is basically we are referencing the import, which is located in the types and the types proto, and we can use it by calling the package that was called common, the name of the package, and then we can access the class. Then additionally, we need to include the reference from that project, and to mention that we have additional import directives, which is basically that class library. Additionally, that we need to do is to add additional context to gRPC tooling that these uh, code behind classes should be of type server, uh, and on the client side we need to say that these are the client. That's the only thing, and that is very important. And here we have a none because we have only Poco classes defined, only models without having any additional logic there. This is the service. This is the method that we are going to have, the request and the response, and this is the payload, and the same types are being referenced here. Basically, that's the same class. In this case, I'm using that directly, but it shouldn't be a problem for us to so that we can copy it. Like each client basically can have their own proto file with the same payload, but gRPC tool is going to generate only for their needs. In this case, for the context of client, and in this one for the context of service. Service is a simple class that overrides the abstraction, inherits from the base class that it was auto-generated. We don't have any extra logic here. We just simply reply on the requests back to the client, and we are registering the service as it is. Mark gRPC service, map gRPC service, sorry, and this is the name of our class, basically, that is here. Everything works like with dependency injection. We can inject our service here, and we can add some extra logic, but for now we have only now logger. And then the last part is basically the client, where we manually instantiating, building the client. We have a channel that points toward the server part. We have a client that takes as an argument that channel and knows how to call the server. It doesn't care about the implementation. It works with the abstraction, so that here you can call the method that are being exposed by that abstraction. And here the method is synchronous, so that we are calling the method from the client immediately with IntelliSense and everything, and we get response back and dumping that into the console. So that's the thing that we have. Let me just write the server first to see if this basic scenario works. So we can see that the server is up and running. When we start, the client is going to write the whole reply message console. This is the message, and this is the GUID that was sent to the server, and we receive the response back. So basically that's the whole demo that I have to present. Thank you very much. I hope you enjoyed watching this video. Till next time. Bye bye.